Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. As always, like we are enjoying a lot and we are learning a lot. We are learning every day a new thing. As same for you guys. Hope the same thing occurring for you. So hope you guys have a proper understanding till this point. If you guys have any doubts, just don't hesitate. Just ping us in the comment section. We will take up and we will solve your doubts. So, guys, till this stage, as always, I'm just mentioning if you guys have come to the session, please make sure that you guys watch all the previous session videos so that you guys can be able to understand what we are saying. Okay, that's the thing. So today it's a continuous session of the previous session where we have introduced you what is support vector, what are the key terms in support vector, how support vector will be useful for classification, and then how it will be used for a regression. So like those things. So hope you guys have watched those videos so that you can have an understanding like a continuation of that session, this today's session. Okay, so today's session is a continuation of SVM that we have explored in a previous session. Let's see what we are having for today. Kernel function in SVM, guys, I will say kernel function is one of the key important thing that are available in the support vector, which makes the things different from all other algorithm. SVM stands out due to this support vector thing. Okay, like support vector machine stands out due to this kernel function. Okay, in all other algorithm there is a static way. Okay, whether the if the data is linear, then only it can able to predict. But in SVM it is not a case. If you are having non-linear data, it is able to predict. Let's see what it is. Kernel function are essential components of SVM, enabling the model to handle a non-linear data. Okay, whenever the data is non-linear, then this SVM will be very useful. Okay, by transforming the data to a higher dimension space, kernel function allows SVM to find complex decision boundaries. Different kernel function offers varying degree of flexibility and complexity. Okay, once you have a data in a high dimension, you doesn't like confidently say it is in a linear only. There may be high possibility that the data can be non-linear. That's the reason SVM works very well using this kernel function. Let's see what are the kernel function we are having. First is linear kernel. It's suitable for linear data, linear separated data. Polynomial kernel. So it captures a non-linear relationship between polynomial function. Consider we are having a polynomial increase in the data points. Then we can use this polynomial kernel. And then RBF, okay, that is what kernel name, Radial Basis Function. So highly flexible and capable of handling complex non-linear relationship. It is also useful for non-linear, but it will help in a complex manner. Polynomial is something which is in a linear increasing fashion. This RHF RBF is like radial basis function. It is like a complex thing where there is no linear increase in data or a polynomial increase in data. There will be a different kind of increase in the data that is non-linear. Finally, sigmoid kernel, similar to sigmoid activation function. Hope guys you already know logistic regression. We have seen right the sigmoid function, S curve that is used in like neural network can capture a non-linear relationship. Okay, so yeah, that is what guys. So sigmoid kernel is like a sigmoid function which is also used to perform the non-linear thing. Okay, so you can choose any kernel based on your dataset. Whenever the dataset is linear, you can go for a linear kernel. If it is non-linear, try to apply all the things: polynomial, RBF kernel, sigmoid kernel, and find whichever works best for your dataset. Okay, hope you guys can understand. Yeah guys, so this is what all about kernels in SVM. So yeah, so that's the first thing. So guys, this is very important guys. I will say support vector machine is something which is unique due to this kernel function as I mentioned always. Okay, yeah, let's move on to the next thing. Okay, this is what the kernel function that we are having. Okay, let's move on to the next slide. Okay. Okay, hyperparameter tuning in SVM. Okay, I hope like this is the same thing that we have looked into in random forest, right? So random forest also have something which is very similar like thing. We will be having a number of trees there, and what is the depth of the tree, what is the max height we are having, like those things we have seen right in random forest. Similarly, there are hyper parameters which are available in this SVM. Let's see what are the hyper parameters we are having. So optimizing SVM uh, performance requires. Okay, optimizing SVM performance requires capturing hyperparameter tuning. Okay, these parameters influence model's capability and the complexity and then ability to generalize on the unseen. The process involves selecting a best values for the parameters like regularization, kernel choice, and then gamma value. Okay, guys, one thing, this everything is already available in the sklearn library. Okay, you guys just need to call it and just need to use it. Okay, but you guys need to know the black box behind it, how it is working, what are the major thing that we are having, where it is stuck. So whenever you guys are not getting a proper output, right, you guys should be in a manner that you can easily able to track it out. Okay, that's the reason you guys are learning the black box of it. Okay, then there is no point of using black box, right? So you guys need to know the black box so that you can able to handle it properly. Okay, let's see what are the hyperparameters we are having. First is regularization, controls the model's complexity, preventing overfitting. Okay, I will say regularization is like a penalty term. Okay, if you guys have watched our introductory section, we will be learning, we will be teaching you about the regularization technique like L1, L2. It is like a penalty thing. Whenever you're training your model, right, you will make your model say, okay, these are the things that is happening. So make sure like you add some more penalty to it. So what happens means whenever you are adding a penalty, right, whenever you just add a penalty, your model will learn further. Okay, so that's the thing. Okay, so rather than using the model, normal model, you will add one more penalty term, so the model will learn more. And what happens means it will start to generalize rather than the memorizing or overfitting. That's the thing. Then kernel choice, it determines the type of transformation applied to the data. Okay, so we have discussed in the previous slide, right? When you are having a linear data, then there is no problem. You can automatically or directly use the uh, linear linear function. Otherwise, you need to choose what function you need. Either it is a polynomial, RBF kernel, or it is something like we are having one more kernel, right? I have just forgotten it. Let's see what is a kernel name. Yeah, sigmoid kernel. Okay, anything, any one of these three you can use for non-linear. Okay, that is what the kernel choice. Then gamma value, it influences the width of the kernel function, controlling the model sensitivity to local data variation. Okay, gamma value is like it shows the width of kernel function. Okay, whenever we apply a kernel function, like to how much extent it need to be used, that is what the gamma value it will, I think it is around 0 to 1. Guys, one thing, make sure you go for the documentation. There are multiple parameters available. So these are the important parameters that we need to work on whenever you are using the SVM. Okay, hope you guys can understand. Yeah, guys, these are the major parameters, that hyperparameters that we are having in SVM. Okay, guys, I hope like you guys can understand. The only thing is like if you guys doesn't understand, please make sure that you just ping in the comment section. We will take up and we will solve it. Okay, so that's a major thing. So we have gone through today kernels in SVM and then hyperparameter tuning, like hyperparameters in SVM. Okay, so moving on, let's see what we are having next. Okay, so yeah, so advantages and limitations of SVM. Okay, so SVM offers several advantages, including its ability to handle high dimensional data. That's true. Its robustness to outlier, yeah, that is also one of the point. And it's effective in both classification and regression tasks. However, it has some limitations such as computational complexity for larger dataset, and it is sensitive to choice of hyperparameters. Yeah, that is what. So what is the advantage? High dimensional data, so data can be in any dimension and any format. Okay, it can be linear, it should not be like in other models. Should be, you will be saying it should be a linear. No, for SVM it can be a non-linear data. So it is like high dimensional data. It can suggest robust or outlier. Yeah, so we will be having even though we will be having a uneven distributed data or abnormal data, it can handle everything, right? So it is very robust to outliers. Effective for classification and regression, yeah, as decision tree, random forest. This is also, this SVM also works for both classification and regression. Okay, yeah, these are the advantages. Okay, as we are having in a coin, we will be having both the sides, right? Head and tail. Consider head as an advantage, then there will be a possibility, lots of possibility to have a limitations, right? Let's see what is the limitation that we are having. So limitation, computation complexity for the larger data set. Yeah, whenever you are having a larger data set, right, you need to convert all the data set to a high dimension. That's the reason like it's going to take more computation time and complexity and sensitivity to hyperparameter choice. Yeah, whenever you are just choosing the hyperparameter, right, consider you are having a non-linear data and you are choosing a kernel as linear, then there is no point and it will lead to a uneven decision. or inappropriate decision. So that's the reason you need to fix a proper kernel value. Then only you can go and handle everything. Okay. So these are the limitation. If you fix a wrong kernel value, it will collapse everything. Okay. So yeah, guys, these are the advantages and disadvantages that we are having for SVM. Okay. Hope you guys can understand. Okay. So yeah, hope this is clear. Let us move on to the next thing. Okay. So yeah, the final thing, application of SVM in data science. Okay. Yeah, SVM found wide application across various data science domain. It is used in image recognition for object detection, in text classification for sentiment analysis, and spam filtering, and in medical diagnosis for disease prediction. SVM also plays a very vital role, or play a role in finance prediction, fraud detection, and other fields where accurate and robust models are issued. So yeah, guys, the thing is, I will say this data science, right? It's a domain which you need to learn so that you can help all other domains. I will say it is not domain centric. Data science is not domain centric and very specific to only data science. No, you need to learn data science and you need to apply data science to the field where you are working. Okay, let's see what are the like applications, as I mentioned, right? First thing is image recognition. Yeah, object detection can be done by using this SVM, object detection image classification. Text classification like sentiment analysis and spam filtering we can do by using this um, SVM. So as sir is mentioned in one of the session, like if there are more text related to free 100% offer, like those things, then they are, these mails are related to spam, like that it will do this text classification and filter. This is spam filtering. Then medical diagnosis, like disease prediction and patient risk assessment, so that proactive decision can be made, so that we can safeguard the lives. Okay, guys, one thing, whenever you learn something, right, try to map it to the mankind. What is the thing that you can give back to the mankind? That's a major thing that we are learning, right? Whenever you are just learning something, like learn in this manner. Once I learn this, what I'm going to do to my mankind. Okay, that's a way of, or a vision that you need to learn. Okay, yeah, let us move on to the application, next application. Financial prediction, stock market analysis, and risk management. Yeah, it is used to find the like forecasting kind of thing SVM can do. Okay, so yeah, hope that is what all about SVM. So I will just have a summary of it. Like we have introduced you what is SVM, what are the key terms that are available in SVM, how SVM works for classification and then regression, what are the kernel function that we are having in SVM, and we have looked into the hyperparameters, how to tune the hyperparameters. Then we have looked into the what are the advantages and disadvantages of SVM. Finally, we have looked into the application. Okay, guys, hope everything is clear. If you guys stuck anywhere or if you guys doesn't do anything, please make sure that just ping me or ping us, okay, in the comment section. We are here to help you guys. I say 100%, like we are here, only here to help you. Okay, so yeah, if you guys have any doubt, just ping in the comment, we will take up and then we will solve your doubts. Okay, so guys, if you guys are to this stage, I will just appreciate your patience, guys, and hope like you are getting things which you guys are like not at all gonna imagine, and the things. Okay, because like we are just saying you what is the black box of each and every algorithm, and we're gonna see the coding part of it. Okay, hope everything is easy and able to like uh, understandable by you guys. Okay, if you guys have any feedback, just let us know, because like we are here to help you and we will just improve you based on your feedbacks. Okay, so yeah, guys, so we have completed SVM theoretical understanding, like black box of SVM. The next session, guys, we're gonna see the coding part of SVM. Okay, so yeah, that's it. That's all about this today's session. So hope you guys have enjoyed. I have enjoyed a lot, guys. Okay, so yeah, guys, um, until next session, bye, guys, take care, and we will all meet in the next session. Bye, guys, take care.